numbers. Yeah, we're going to talk about Prometheus in this session, and maybe for a quick show of hands, who here is already using Prometheus to monitor their infrastructure? Oh, okay, that's more than half, I would say. That's good. I hope it's not going to be too boring, because I will give a quick intro to Prometheus and PromQL, and originally the goal was to give you, an easier start with Prometheus, but I'm quite hopeful that I can show you a few tricks that might be helpful to you. Yeah, so for a quick agenda, so intro to Prometheus, the Prometheus project. I'll shortly talk about exporters. We'll look at configurations and deployment considerations, and I'll give a quick overview over the query language and show off some what I think are really cool features in PromQL and that make Prometheus such a good monitoring solution. All right, yeah, let's get started. So Prometheus was originally developed in 2012 by SoundCloud. It was inspired by Borgmon, which is, a Google internal infrastructure project. So, no surprises. It's a CNCF member project. It's, quite widely used. It's built for highly dimensional numerical data. So that means it's not a log analysis system, and you can't really send any text metrics. It is designed for simple operations, and I hope I can make that quite clear. And it's also meant to be very scalable. And part of that is that Prometheus is a very approaches monitoring differently from many other projects that are currently used, and that is that Prometheus is pull-based. So it pulls in the metrics from the endpoints, which gives it quite a few nice properties when you consider deploying more Prometheus instances, and also the scheduling for metric scraping becomes a lot easier because Prometheus can itself decide when to get metrics instead of being hammered by 10,000 endpoints in 1 second. Yeah, it comes with a powerful query language, PromQL, and it's, I think, quite beautiful too. And yeah, as I said, it's quite widely adopted. I just stole this picture from the Prometheus website. There's obviously way more users than that. SUSE is using it, of course. And yeah, many of you are too. So one component I would like to mention explicitly is the alert manager. It is part of Prometheus itself. Though you can definitely use it without Prometheus. It's just exposing a HTTP API. The reason I want to mention it here is that this is basically the only component in the Prometheus stack that is aware of clustering. So when you have multiple alert manager instances, you will need to tell the alert managers where to look for their counterparts, because as you can see, they handle the alerts. They do deduplication of alerts and stuff like that, so they need global state. Yeah. This is the only component that needs some clustering, and it's quite easy. You just pass a list of peers in the CLI arguments. Yeah, there's no big magic behind it. I just wanted to mention it. Yeah, and the other side of that are the exporters, of course. So there are, of course, many exporters. Ceph has a manager module that is an exporter if you're, Luminous or newer. And exporters are actually quite nice. They expose a simple HTTP plain text interface, which makes them quite easy to write and quite easy to look at. When you start looking at exporters, you will come across the node exporter first, of course. That's the one that exposes general host metrics. But pretty quickly, you will look at maybe writing your own exporters as well. That's a thing that one arrives at quite quickly, I find. The idea behind that is that Prometheus recommends not having exporter daemons that collect metrics and export them, like the node exporter does, ironically. But ideally, software is directly instrumented. So you will, ideally, you have your code, and you put the instrumentation code right into your code and have your software expose Prometheus metrics. That, of course, is for existing software that is quite hard to do. So there is a lot of software that has a daemon running next to it. In Ceph, we get to do it with the manager. That's kind of in the middle. But if you ever want to write an exporter, there is some guidelines on how to do it at best. Exporters usually have only very basic metrics and are encouraged to do so. So basically, any processing that you would do in the exporter, don't do it. That can be handled in Prometheus quite efficiently. For example, don't give a rate of network throughput. Just give it a byte count. The rate can be calculated by Prometheus quite easily. And usually metrics you will find in base units, like seconds or something. It's not recommended to have a millisecond metric or something like that, because again, that can be done in Prometheus itself. Just a quick look at how such a metric would look. So first of all, this metric, I'm going to use this throughout this talk, basically as a placeholder for other metrics, partly because this metric name is nice and short, where the metric names in Ceph itself are quite long, so it fits on my slides nicely, and it isn't actually that interesting. I'll just tell you what the metric currently does. So if you expose a metric, you start out, or ideally you start out with these two comments line on top. That is a type hint for Prometheus and a little help for the user, so you can have a little short description of what the metric actually describes. And then you have the actual metrics. So you have a metric name, in this case, Ceph my metric. You have a list of labels in the curly braces, and you have a value. And the list of labels is really where this metric gets multiple dimensions, right? You can have a whole list of these metrics, and they will only differ in the label values. And if you're interested about more in writing exporters, check out the Prometheus docs. There's quite a bit of text about that. Okay, let's look at how to configure Prometheus. So it's quite simple. You can influence the daemon behavior through some command line flags. Daemon behavior would include such things as the port that Prometheus uses to expose its time series database, the path where it stores the metrics and such, and the configuration file, which is a YAML file, configures the runtime aspects. So you can see, the default scrape interval and things like that, and of course where to scrape things, which is the most interesting part here, of course. I have actually on the next slide a few words to lose about service discovery. So these scrape configs, as I said, they tell Prometheus where to go look for metrics, and there's various service discovery methods that you can use. This one is a very simple one, static config. You should really only use this if you have well-known names that you want Prometheus to scrape. In this case, Prometheus exports metrics about itself too. So if you have a Prometheus instance under this host name, you can do things like that. But generally, I would discourage using static configs right in the file, because it's very inflexible. There is a whole bunch of service discovery integrations. For example, Kubernetes has an API that Prometheus can query for all the various Kubernetes components. That's already much nicer. You can, limit the targets by a role that you have. Like it can be, a node that runs certain containers and pods. It can be a service or a pod. Endpoint and ingress are others that you can monitor here. And that gives you nice and dynamic targets. The one file service discovery that I really like, though, is the file-based one. And this may seem a little strange. At first, I was kind of like, this seems very clunky and not, not straightforward. But I've come to really like it. So how this works is you give Prometheus a list of file system globs, and it will evaluate these globs and try to find the files behind those globs. And these files only contain static config fragments like you see on top. So now you can do, you can go out and use your favorite config management system or whatever you have to deploy new hardware and just have it drop a file in this directory and Prometheus will pick it up. Or you could even, come up with a really fancy glob and have Prometheus pick out the right files that it wants. And it's just very versatile. And if you have targets that don't fall into one of the service discovery integrations like Kubernetes or so, this is really the one that you want to use. There's actually kind of a guideline upstream Prometheus that they won't develop any new service discovery integrations because everything can be handled by this file SD config. They would recommend you to just, write a little daemon that updates the files accordingly to what you want and stuff like that. That's, again, very, very flexible. And if you don't use it yet, you should look at using it. OK, so with configuration out of the way, you might want to consider what things you want to, or how you want to monitor your systems. Monitoring is obviously for diagnosing problems and being aware what's going on. So, monitoring should be resilient. That shouldn't be the first component in your stack to go when something goes wrong, of course. And once you actually start monitoring with Prometheus, you very quickly arrive at a point where you react like this, basically. So the second point here is that your monitoring should scale, obviously. You want to monitor everything. So how can this look? So typically, you start out like that, right? You have your infrastructure, you have a Prometheus node, maybe a Grafana on top. That's not the important part here. This is neither of the two, of course. So if your Prometheus goes, you don't know what you're basically flying blind. So the first thing you do, put a second Prometheus in. And that's like ridiculously easy, right? You basically just replicate the config you already have, and you're done. The only exception is the alert manager. So you have to make the two alert managers aware of what you're doing in case you do Prometheus alerting at all. So next step, what happens if you, run a really huge infrastructure? And by huge, I mean, beyond tens of thousands of nodes, because Prometheus can handle that quite well. Well, you start partitioning things. So you have two Prometheus instances, and you partition your infrastructure into two parts, and just scrape them like that. Again, fairly straightforward. The config is generally the same, just the targets differ. And I, gave a glimpse of what would be necessary to handle that with various mechanisms. And then, of course, put these two things together, and you'll start looking at things like that. Then you want to think about, your visualization. You probably want to run two Grafana instances or something like that. And there's, of course, a whole universe of configurations that look kind of similar like that or not that you could run. Point is, you will very quickly arrive at multiple Prometheus instances, and you should. It's really meant to be handled that way. OK, so let's look at the actual interesting part. So since there are actually a few people who don't use Prometheus yet, I'm going to give an intro to the query language. I hope I'm not going to bore people too much, but we'll get to some interesting queries a few slides down. So PromQL. Again, it's a very nice query language. It's statically typed. So you have a bunch of types that you deal with, and the operations are well defined on certain types. The most interesting types are instant vector and range vector. There is a few simple types like strings, scalars, and stuff like that. Those are not too interesting. Of course. What is an instant vector and a range vector? So an instant vector gives you a single value per metric and timestamp. So that implies you have to give it a timestamp, and you get a single value back. By default, if you go into the Prometheus interface and query Ceph my metric, you get the latest value, but you can also query further back. A range vector, the name gives it away already. It gives you a range of values for a time range. per metric. So far, so easy. Some basic things that we want to get out of the way. So you can do some label matching in your queries, match against a value or against a regex or a substring kind of match, or a negated match. That's, should be fairly obvious. I'm sure most of you know this. So, you can exclude certain label values and so on. You have a bunch of binary operators, so basic arithmetics, of course, comparison. The comparison and arithmetic operations, they operate on vector values if the labels match. That is always an interesting thought process before you get to that. And you can control, on what labels it will match. We'll come to that further down. And these basic operations are defined for any combination of scalars and vector values. Of course, if you say, work on use these operations with a vector and a scalar, of course, the scalar gets applied to every value in the vector. That's fairly obvious, but yeah, I just wanted to mention it. For two vectors, there's a bunch of operations that only make sense with two vectors. So and, or, and unless they return new vectors if the labels match of these two vectors that you use. And as I said, you can control which labels Prometheus looks at for this matching. So by default, it will try to match all the labels. You can tell it with on to just match, a label or multiple labels, or you can just ignore a single or a bunch of labels. And there are some aggregation operators, the stuff you would expect. You can sum up stuff and things like that. That usually happens across all label dimensions, and you can control the result, the labels of the result vector with by and without. I'm sure nobody's really taking this in. Look up the documentation; it's quite nice if you want to go in depth with that. And last but not least, there are functions that they're mostly a matter of convenience. I think you're able to implement all these functions with the more basic operators. But there's a whole list that are very interesting and are just so much easier to use than implementing things yourself. And we'll use a couple of those in the examples that are coming up. So yeah, we'll see some of those later. Again, there is very good documentation. Read it up. It's much more than I can do here. Okay, so let's look at some queries. Simple queries. That's probably stuff I'm going to bore you with. Again, matching with a label. We had that already. Having two metrics and deducting them from each other. By the way, I know I introduced a new metric here, but this is a pattern that you will see quite often in Prometheus. I mentioned in the beginning that Prometheus recommends on exporting like a minimal set of metrics. So you will often see, for example, for file system usage, you'll see a size metric and a used metric. The free space you can easily calculate from that. So of these like triples, size, availability, and used, you will usually see only two, and you'll have to calculate the one that you want. So that's why I mentioned this query here. And of course you can, sum up very easily. And you notice with the aggregation, you lose all the labels because it aggregates over all the label dimensions, and you'll just get a value or an empty vector essentially. It goes to cardinality 0. That would be the appropriate wording, I guess. And as I said earlier, it's also frowned upon in Prometheus to expose like throughput rates, because you can really easily calculate that. So this particular metric, or this particular query, gives you the per second rate of this metric averaged over the last 5 minutes. So you can see it's a very concise syntax for quite a complex query, actually. Okay, I realize I'm going quite fast, so let's look at some more complex queries. So we have now our Prometheus setup. We have a bunch of metrics. And by the way, I see a lot of people taking pictures. There's a link at the end or a QR code. You can grab these slides of GitHub. So you know, it's all there for you. All right, so we have a bunch of metrics from our exporters, and for example, we have the node exporter and our Ceph exporter. Now we want to correlate metrics across exporters. For example, it would be really interesting to see for an OSD what are the smart values for the drive behind the OSD. We get the smart values from the node exporter. And we get some OSD metadata, like which drive is it using from our Ceph exporter. So how can we make this metric happen? How can we ask Prometheus for how many reallocated sectors does a device have that an OSD runs on? Well, we use the the vector matching. So we reallocated sectors is actually called something hideously long. Oh, I have it up here. I'm just used the short version here. And the reallocated sectors metric has, of course, a device label in it. And incidentally, in our Ceph metrics, we have a metric called Ceph OSD metadata, which carries the device a particular OSD runs on as a label. So we can ask Prometheus to match these two metrics on the device label and give us the reallocated sector count for that. What I left out here in the label list is actually the OSD label is in there too. So you actually get the OSD ID for this particular count. Of course, that isn't always that easy, because sometimes the labels don't quite match. Well, there is a label replace function that way can start messing with the actual label values and just make them behave the way you want to. And of course, you can also, add the label matching here and ask for the reallocated sector count for one specific OSD. That's the label, by the way, that I left out. The Ceph daemon label, a lot of the Ceph metrics carry this. And you'll get metrics for various Ceph daemons. Another nice application of Prometheus is that you can look to the future. Of course, it's good and valuable to know that your OSD is now full and is no longer serving requests. But it would be nice to actually get a warning before that happens, right? So of course we want to know when it's full or if it's full, but we also might like to know if it might fill up like in the next day or so. Well, we can do this. We can do this very easily with predict linear. So this does a linear prediction over the average of the last hour, and the other value you give it is for how long you want to do the prediction. So this would be, I think, 4 hours. Which is already quite nice, right? I mean, we can now look into the futures for 4 hours and see how full this particular OSD might be. Even better would be if we actually can get a time of that, and we can. With some, clever math. It's actually not that clever, but I'm not going to go into how you arrive at that. You can actually ask the Prometheus to give us a prediction of when this metric is going to be full. So what we do here is use the size and the usage to get the free space, and essentially ask it with the current average fill-up rate over the last hour, give me a derivative, and that essentially tells us, okay, in how many seconds will the free space in this for this metric be 0? And then you can do some alerting on it, which I find quite nice. So that's a glimpse into Prometheus query language. The same thing you would use for alerting. I'm not going to go into alerting here, but the same query language you can use for alerts. The only limitation is that the query should return a true or false, because that's what the alert goes on, right? So we have this metric that we just looked at, and basically this alert will alert you if something fills up within the next hour, and that's some quite useful alert, I find. You can, I mean, we can quickly go over this alerting syntax a little bit. So you basically just give it a name, an expression that we talked already about. You can add a for clause where Prometheus won't alert you if this metric has only been true for 4 minutes. It'll wait for 5 minutes for this metric to be true before it actually alerts you. And the labels are just for you on the other side to find some good metadata about this alert. Right, and all this you can actually look up in the upstream Ceph repo already. There is a number of dashboards, and there is also a small number of alerts. That is kind of like a base set that we would recommend you look at. I'm sure, I think most of you would probably use it as like a starting point and pick out a few pieces that you like and then add your own. If you have things that are missing there that you think should be in those default alerts and dashboards, please contribute them. We're always happy about PRs. And of course, there is a whole galaxy of things that we didn't cover here. So we skipped over most of the alert manager. There is, of course, the whole visualization path. Grafana is something that a lot of people use, but there's, of course, others that you can use. Federation can be interesting, where Prometheus instances scrape other Prometheus instances. There's some nice things you can do with that. Push gateways are interesting for things that are like one-shot operations, and you want to get some metrics about these. Recording rules, label rewriting. There's a whole bunch of stuff that you can get into. And with that, I am done, and I think we have time for questions. And I don't know if we have another microphone, but I don't think so. So if you have a question, ideally come to the front, and then I can repeat the question and answer it. And you find the slides here. So yeah, thank you. Okay, the question was what kind of hardware requirements for storage and such do we recommend? And that's tricky to answer. The time series database itself is quite efficient at storing data, but of course it depends on a lot of factors. Like, you don't necessarily have to scrape all the metrics from an exporter, for example. I think we kind of, rule of thumb that we kind of came up with was something in a Ceph deployment where you have the node exporter and the manager module. I'm not quite certain, but I think it was something like 100 megabytes per node and per week that you want to keep data for, or something like that. I'm sure there's others who can answer that more precisely, but storage it's significant, but it's also not insanely high. And as for general hardware recommendations, I have not seen a cluster yet where Prometheus, generates any significant load, really. Like, you have to get really, really large. And I know there's people out there who have Prometheus instances that scrape tens of thousands of nodes without much trouble. So, if you ever run into any resource issues, I would love to hear about them because I haven't seen them yet.
So I've seen issues with the manager not being able to keep up with all the performance counters in large-scale issues. Have you seen that? What's the biggest improvement you've done?
So the question is that Vido has seen issues in the manager daemon keeping up with all the performance counters that are then becoming the metrics that are exported in very large clusters. And the biggest cluster I have seen was, I think, about 100 nodes and a couple of thousand OSDs, and that wasn't an issue so far. I know that the manager, that is becoming an issue. The more load we put on the manager with the dashboard now and several exporters, we'll have to see how to attack that. But if you have seen any problems, we should start talking about that. Sorry, he was first. Okay, yeah. So the question is downsampling. I think I forgot to mention that. Yeah. So Prometheus is not meant to be a long-term monitoring solution technically. So by default, I think it keeps data for 15 days. Of course, you want to do that longer. The trick is either to use remote storage, so you can push all that data into, blanking on the name, there's another time series database that can feed data into it. Or you use the federation feature where you have one Prometheus instance scraping, your short-term instances, but they only do it like, once an hour or 2 times a day, and then you keep this data for like 5 or 10 years. So
your whole future, how far are you
on trend analysis? For upstream, you mean? Okay, so the question is, with those prediction metrics, how far are we for trend, how far are we with trend analysis in the upstream stuff? And there is a few panels, I think, for the pools. There's a pool dashboard, so for pools I added this particular metric. This should be added for certain mount points on the node exporters. And otherwise, I'm just a developer. I'm not an operator. So if operators tell us what they want to look at and what trends they want to look at, we can get this in there. That's not a huge issue. It's just a matter of knowing what to look at. So if you have ideas, open a tracker ticket or a PR even. Okay, any more questions? Nope, that's it then. Thanks, guys.